caffeine has no capacity for altering your energy production. So ATP is the molecule of energy for cells. If something is going to give you energy, it has to be affecting aspects of ATP and energy production. The most misunderstood component of caffeine is that people think it gives them energy. It turns out that from the moment that you woke up this morning, there's a chemical that starts to build up in your brain, and that chemical is called adenosine. And the more that adenosine builds up, the sleepier you feel. Caffeine will come in and it will latch onto what we call the receptors, which are these welcome sites in the brain for adenosine, but it doesn't activate them. It blocks the receptors. So think about a room full of chairs. And normally the adenosine molecules are going to be sitting down on those chairs, which are the receptors. Caffeine races into the room, and with some quite sort of effective elbows, it will take up and occupy all of the seats. So the people are still standing in the room. The adenosine molecule, the sleepiness pressure is still there. It simply can't tell the brain that you're sleepy because the receptors are no longer available. The seats are occupied by the caffeine. And here's what happens. You don't go back to the same level of sleepiness that you had when you consumed the caffeine. It's that plus everything that continued to build up with adenosine in the hours that the caffeine has been in your system. So now what happens is that you crash. Ask the question in some ways, when is caffeine most strategically useful to you? And one of the ways is when you're trying to have a focused sort of demand of brain performance. And caffeine, we know from scientific literature, is very good at improving what we call your focused attention. Also your reaction times, your speed to respond, so you can process information more quickly, because there are times when you know that a distracted mind makes for inefficient work. If you're taking on more strategic, smaller doses of caffeine, let's say 50 to 100 milligrams, that's going to be more optimal. But with coffee, it's a little bit of a wild west. You don't quite know how much you're getting, how long it's been brewing, etc. The nice thing with having a standardized dose that you can get through some type of mechanism where you can see it on the label, you know exactly how much. It's a great way for you to actually firstly understand how much caffeine am I consuming relative to what I quote unquote need to get me where I typically want to be. And you can be your own scientist, experimentally quantify that, and then gradually you can just taper yourself down in a very precise way, and then you can bring yourself back up. So there's benefits to having, not quite the Wild West of give me a cup of coffee and fingers crossed, versus a packet where you know precisely how much you're getting. Caffeine is actually a diuretic. What that means is that you will start to urinate more. When you're urinating, you start to excrete critical minerals, sodium, potassium, magnesium, chloride. Sodium and potassium in particular are critical for the firing of your neurons. And the way that your brain works fundamentally is that those neurons have to fire, transmit signals, accomplish operations. That status of the brain, its environment, its state of mineral hydration versus dehydration, can change so much about how efficient it's going to be in terms of transmitting information and also consuming information. We often think about, I need to hydrate the body. Don't forget, you need to hydrate the mind as well. The mind is critically dependent just as much, maybe if not more, than the body. The message here is it's not about necessarily abstinence. It's about just trying to be responsible with your use of caffeine and thinking about that timing. Caffeine has a half-life of about 5 to 6 hours. What that means is after 5 to 6 hours, about 50% of that caffeine is still in your system. It turns out that none of us are the average adult. There's a huge range in how quickly the brain and the body is able to excrete the caffeine. And there is a liver gene, and it's called the CYP1A2 gene. If you have just a few changes in the DNA nucleic alphabet that codes for that gene, you can clear caffeine in as little as 2 hours in terms of the half-life, Or you can be someone who is a very slow metabolizer, and it can take you 12, even 14 hours rather than 5 to 6 hours. That is the average. Keep in mind that there is a big range. I would say, though, that if you look at the population, more people are actually caffeine sensitive than caffeine insensitive. Almost everything that we're discussing is the Goldilocks phenomenon, which is not too little, not too much, just the right amount. The dose and the timing make the benefit or the poison. And the way that you can know I overdid it was, firstly, your sleep is not wonderful at night. You're either fragmented, you're struggling to stay asleep. Sometimes you don't feel restored when you wake up by your sleep in the morning. But the other thing is, during the day, am I just feeling a little bit too wired? And sometimes it can cause me a little bit of anxiety. That's again where just having these moderate doses in that sort of, 50 to 100 milligram range, that's ideal. So really, that's where you get to the optimal utilization of this wonderful, in some ways strategic tool that we call caffeine.